All right, welcome to the first example of section 7.3. So in this chapter, we've been working with rational expressions. And remember, rational expressions just mean that we're working with an expression that's a fraction that has a linear or greater expression for the numerator and denominator. Or it could be a constant. It's just an expression that can be represented by a fraction. So we've looked at what the graphs of rational expressions looked like, and we've seen how to identify some features. We've also seen what direct and inverse variation look like. So far, the expressions for the numerator and denominator that we've looked at have all been linear or lower degrees, so only constants and linear expressions. Now we're going to start looking at polynomials with degree of 2 or higher. So all your rules still apply to these types of expressions. We can add these expressions, we can subtract them, we can multiply, divide, we can do all of this. And you've already learned most of the rules. You've learned how to multiply polynomials, you've learned how to divide polynomials, you've learned how to add and subtract polynomials. So really you already know this. It's just a matter of being able to recognize when you need to use the correct operation. So before we get into these operations, what we want to look at is how to simplify rational expressions. As you know, by working with fractions, whenever you try to combine fractions, it's always helpful if you're able to cross-cancel or simplify or factor out common terms or common factors within your numerator and denominator. And the same thing applies for fractions, for rational expressions. So if we go, I want to show you one of the core concepts in the journal. So one of the properties that we're going to use when we simplify our rational expressions is this first one. So if we have a fraction, a rational expression that has a common factor in both the numerator and denominator, we can go ahead and cancel that out. So you see right here, if we have, let's say, just two expressions or two terms, a and c for our numerator, and then b and c for the denominator, if we go ahead and try to simplify that, we can actually cancel out c because it is common. Now, one thing that I want to clarify with you, this works if we are multiplying together. Now, if we are trying to, if our expression looks like this, if we have a plus c over b plus c, this does not work. We can't simplify, we can't factor out c. Because remember, when you're working with polynomials, you have to remember that these are protected. These terms are protected together by these parentheses. So this right here, you cannot cancel out. This is a no-no. Now, if you have a times c over b times c, you can cancel out c. This is okay. And that would just leave you with a over b. Now, an example with numbers plugged in, let's say right here, if we had 15 over 65, we can tell that that is a common, we have a common factor. Both of these are multiples of 5, so 3 times 5 over 13 times 5. So we can just cancel out 5. Now this is something you've been doing ever since you've been working with fractions. This shouldn't be anything new to you. But I'm refreshing this because when we're working with rational expressions, you're going to see that we've got polynomials or multi-term expressions in the numerator. So the same rule applies. So if we had an expression that looks like this, 4 times parentheses x plus 3, and then on bottom we have x plus 3 times x plus 3, we can cancel out 1x plus 3 from both the numerator and denominator. And we're left with the portion that was not canceled out. So 4 over x plus 3. So you're going to get better at this as we go through the chapter and practice. But remember, you can only take out the same number from both the numerator and denominator. Okay, you can't cancel out both x plus 3's on bottom because you only have one on top. So you're taking out just one. All right, let's go look at our problem here. So we've got x squared minus 4x minus 12 over x squared minus 4. Now, I want to show you a couple things that you cannot do. So if you look here, we've got an x squared on top and an x squared on bottom. A lot of people will try to take those out and say that we're left with negative 4x minus 12 over negative 4. That is not okay. Absolutely not. You cannot do that. Remember, your polynomials are protected by parentheses, and you can only take out the same polynomial from both the top and bottom. Unless it's a coefficient that is multiplied by your polynomial, you cannot cancel out. So this is a no-no. We can't do that. So please remember that. I'm going to be very disappointed if I see that on your homework or your tests. Do not do that. You can't take out just part of your polynomial. All right, so let's go back. Now, another thing you can't do, look at, we have a negative 4 right here. I see this happen a lot. Students go like this and then say we've got x squared minus 12 over x squared. A lot of times we'll try to cancel both of these out and say we're left with x minus 12. That is not okay. Again, do not do that. I will not be happy if I see that. So what can we do? So when you've got your polynomials like this, it might be difficult to see what the common factors are. But you learned a couple chapters ago how you can simplify your polynomials here. And that's what you want to do. That's the first step towards solving this. You want to make sure you get any polynomials in simplified form. So let's go ahead, and what we want to do is factor both the numerator and denominator. So when we go ahead and factor that, we see that x squared minus 4x minus 12 is just x plus 2 times x minus 6. X squared minus 4 is just x plus 2 times x minus 2. So what you'll see right here is that we've got a polynomial on top and a polynomial on bottom. Both of these are complete polynomials surrounded by parentheses. They're identical and they cancel out. So these two will cancel each other out, and that is perfectly fine. Again, as long as you're taking out the entire polynomial that's protected by parentheses and you've got the same expression on top as you have on bottom, that's okay to take out. And what you're left with is going to be x minus 6 over x minus 2. So we've taken our common factor out, and what we're left with is x minus 6, x minus 2. Now, when it comes to writing down what we can't have, you'll see that if you look at our original, we've got x squared minus 4. Now, we need to note that x cannot equal negative 2. Now, here, it looks like negative 2 would work. We'd have negative 2 minus 2, which would give us negative 4. So we'd have negative 8 over negative 4. But if you look back at our original equation, which is what we want to work with, negative 2 plugged in here would give you 4 minus 4, which would give us 0 as the denominator, which is undefined. We cannot have that happen. So we have to denote that even though it looks like it would work here, it still can't, because your original function is what you need to check for the domain and the vertical asymptotes. So it's important to write that down. Now, we know that positive 2 is also not going to work. So when x equals 2, that's also going to be part of our domain, the restriction on our domain. But right here, that's very obvious. We have to denote that x can't equal negative 2 because it's not as obvious here. Okay, so what I want you to do is give this example right here a shot. So I want you to simplify x squared minus x minus 12 divided by x squared minus 9. Go ahead and write your answer in the text box. And if there's any terms, any values that x cannot equal to, make sure you write them down. If it's not obvious from your answer, make sure you write it down, just like we did in the first example. Just like we had to write down that x can't equal -2, make sure you write down any values that are not obvious. Okay, that's going to be your first one that you're going to work on right now.